Hello, welcome all of you.
Mm.
Hello, guys. Good afternoon, all of you. Welcome to, I don't know the number of the session. The thing is the third or fourth session. Without much discussion, I would like to, by the way, do you all listen to me? Just write yes or no. Don't tell me yes. Okay. Write down yes or no. Do you all listen to me? Yes, sir. Okay. Good. Guys, yesterday we had a discussion on, is it going on? Yeah. We had discussion on descriptive analytics. I explained you how to compute the summary statistics along with visualizations. I had explained you how to make very few graphs. Unfortunately, within this 40 minutes, it is not possible for me to explain entirety of a concept. I'll just touch the concept and then leave rest of the activity to you. And I mean, today you don't need any teacher or a textbook to study data analytics. It is my personal feeling. I do see a lot of people studying themselves just based on. You will understand the significance of my statement if once after you become employee in some software company. I mean, if you become a data scientist, then possibly you will understand. By the way, all of you are able to listen to me, I guess, right? I assume that you are. So everything is okay. Now, straight away, let's go to, I'm just going to share my, by the way, welcome to my Ubuntu operating system. In my last session, I used Windows. As I said, my Windows is a multi-machine. I was not able to operate Jupyter. Okay, but Jupyter is very important in this, right now in this situation, you need Jupyter. Somebody called Jupyter, I call Jupyter because the pi is very important. I like to pronounce through Python. If you see the Jupyter is opened in my. So yesterday there was something. It was some portal name, right? There was a person. Now you see it is a local host, and Jupyter was opened on my port number 8888. Okay, how I did that? I mean, I just would like to show you. I mean, a few of you might be. And I'm using Ubuntu 16.04 in my computer. It is a dual boot machine. I have both Windows as well as Ubuntu. Let's say first I installed all requirements for today's session. They are NumPy, SciPy, Matplotlib, Seaborn, Pandas. You see P3 install NumPy. This how in Windows you don't need 3. You just have to. If you have Python 3, you can just straight away install them by pip install, something like that. And then I install Jupyter here, Jupyter. Pip3 install Jupyter. And then it installed all. There are quite a few requirements for this Jupyter. Let's see how many requirements are. Then after that, I don't need to go to the installation directory, but in Windows, I think if the environmental, I mean, the environment is not set properly for Python and the Python scripts, then you have to go to the installation directory. From there, you need to execute the command Jupyter notebook, like that. Okay. Somewhere I think I issued that command. Yeah, here. The Jupyter notebook. Now the Jupyter opens with all its information, give you a lot of functional information. That is just, I mean, there is some security issues. Jupyter is going to make use of the token. Here you see that, so that, and now the file, your file is going to be here from this server. You access the notebook, open the file in the browser. So here, this is the address of the file. Home MK, this is my home directory. In MK, there is a invisible file folder local, and share Jupyter, something like this. Okay. You can also, I think, okay, that's fine. And now I straight away can, I think, I don't know whether you are able to see that. Till now, I opened my, I've shown you my terminal. I think you wouldn't say, by the way, why there are only 18 individuals today? The rest of the individuals are not interested in this class? No? Okay, fine. So I'm happy at least there are 18 students.
Sir,
Okay, now.
some of them are having internet problems, sir.
Okay, okay. Sorry. Now you see when I open the Jupyter notebook, it will straight away.
Good afternoon, sir.
Good afternoon. Good afternoon, all of you. So can I mute you all? We'll have discussion at the end of the. I am already on. So I'm just going to mute you all. Huh? Good afternoon, all of you. Now you see the Jupyter opened in localhost. So here localhost 8888, and now after you come here, you just have to press new and then Python. Then that will open new press new. That will create another tab in which you can just try to from here onwards you can. Well, okay, it's all right. That's okay, fine. So I thought people are. I don't know how interesting my sessions are because most of the time people are when they don't digest data science and analytics. Unfortunately, I am very much interested, but I don't know your level of interest in data science and analytics. Okay, let me imagine that all of you are interested in data science and analytics. Otherwise, it's not. Today's concept is going to be the chi-square test. So yesterday I explained you the descriptive analytics. I've shown you how to compute the summary statistics and then also a couple of visuals. I think I've shown you scatter diagram, and I was trying to plot a histogram. It was not possible for me, and I was also trying to plot a box plot. It was not possible for me once again because we need convenient data. Anyway, that is not a big thing. You can just go to matplotlib examples, and there you can copy paste. I can still discuss, but I don't like to waste my time because I have quite a few things to talk to you and related to. They're all related to statistical analysis. In this class, I'm going to talk about chi-square analysis. I think all of you know chi-square analysis, right? Is there anybody who don't know chi-square analysis? You have to write yes or no in the chat. Don't talk to me. I assume that all of you are aware, not only aware, I think you already done some analysis using SPSS. Suppose is there anybody who don't know chi-square analysis, then go to Wikipedia. That's all, Wikipedia. Just don't go anywhere. Don't download any textbook or neither. You don't need to go to the laboratory. You just have to go for Wikipedia. There you have abundant of information related to chi-square and the different methods of chi-square and chi-square significance test, and there are also examples. See here you can. This is actually whenever we are performing chi-square, you just have to imagine that we will be computing this mass known as chi-square statistic. Observed frequencies minus expected frequencies to the power of 2, I mean square whole square divided by expected, which in short we call O minus E whole square divided by E. It is not E square. I many times I confuse this E square or E. It is just E. You see here, if you observe very carefully, this is close to G distribution, Z distribution, which means normal distribution. It is a Z square. Something chi-square is equal to Z1 square plus Z2 square, Z3 square. Suppose if you have n variables, n number of variables, if you compute Z statistic for all these variables, and sum of the squares of those G statistics yields chi-square statistic. That is why the chi-square is a robust statistic, because it is just aggregation of all the. So you have to, that is theory, and once you have the chi-square statistic, you can convert that into any number. I mean, any type of statistic. You can convert chi-square into T, convert chi-square into F, Z, and all. There are a few other statistical statistics And sometimes we can also convert a t into chi-square, z into chi-square, and f into chi-square. There are many methods. R into chi-square. R can be converted into t, and from there you can convert into, if it is a large sample, it is z. And z can be converted. If you square it, then it will become chi-square. And this chi-square play a huge importance. Very important role. Very important role in statistical analysis, because in multivariate analysis, in factor analysis, we use chi-square. In EFA, exploratory factor analysis, we use almost all multivariate techniques. They do use chi-square. We do use chi-square analysis in almost all multivariate techniques. This is very important. Now, how to do this chi-square analysis in Python? I have this. I'm just going to start Markdown. Yesterday, I told you how to do this. I'm just there are Markdown. You can use HTML, also LaTeX. I've shown you how to do that. I personally like LaTeX. Today I'll use LaTeX. Okay, that's LS Magic. Shift Enter. I think you don't have. Let me see magic methods in Jupyter. I want to show you because that's very important. The doing analysis is not kind of shortcuts and Jupyter tips and tricks, built-in magic commands. Hi Python. Why I am teaching you in Jupyter? Because I want you all to submit me the reports in either PDF, Markdown, or say how to list magic. Yesterday also I was not able to. If I have to my Jupyter magic Jupyter. I think LS I'm sure, but after that I don't know what are all alias. LS magic, yes, LS display list of. I'm sure I'm doing it correctly. Display list of currently available magic functions. But why I am LS magic? Let's go back and say, let's say, is it Shift Enter or run with. Let's go for cell run. It's not coming. I don't. Anybody, if you know, run cell type, current output toggle, current output toggle scrolling, clear, all output toggle. Not good. Now, say for example, I have X. I go to 1, Shift Enter, X, Shift Enter. So it is coming. But why this is not being executed? Anyway, that's okay, fine. Let me delete everything. They're all shortcuts for this. This is cell. There is also shortcut for this. Yesterday we were. I'm still not delete cells. Delete cells because I don't use this. Okay. So now ls magic shift enter is not coming, but there is a function called let. Okay. Now I can just go by title. If I write like this, this is let a command. Okay. You see in LaTeX, if I put correct and then square analysis, it will be. Let me shift enter. Title LaTeX. Chi-square analysis. Okay. So I'll see. I don't like to waste my time. Let me go for. I'll go first to chi-square analysis. No, I think. Okay. It should be marked down. I don't know. latex uh, title title let's go back here and say Maga. It's not coming. Okay, fine. It's not coming. Okay, fine. Chi-square analysis. Okay, this document is describes. Okay, so that's something like that. Now I'll go back to code and here. So now what I'm going to do, I just simulate some data sets and perform chi-square analysis. For that, I can just make observations. First, import numpy as np because we need and import scipy stats as from scipy import stats. So I need this to I need stats for stats. Now it is not yeah, okay, implemented. Now you see here you'll find the six, which means sixth. This is the sixth execution statement. The sixth statement which we execute, sixth cell or sixth iteration in our code, something like that. Now let's go for I create observations and the np array, and here in this array I'm just going to put some numbers 1 comma 2 comma 3 comma 4 comma 5 6, some routine numbers, and okay, let me put till now. When I press observations I should be able to see that. Now for instats we have uh, a command called chi-square. If I put stats and press enter, I should be able to see, press enter, I should be able to see, you see chi-square contingency chi-square. So I use chi-square. You can use anything, whatever, chi-square, okay? And then we just have to hand over the observations. Now what we are trying to do is chi-square, chi-square, okay. So you see here, you got chi-square statistic along with the p-value. Now, if you look at it, now how are you going to? Because yeah, my internet connection is not stable. You have to be cautious. At any time, it may disconnect. Now, doing see, there are three things in every analysis. You have inputs, and you have analysis, and you have outputs. So you have to explain what is your data, and what is your analysis, and so I'm not doing everything in a systematic way because I have time constraint. But you should not do your analysis like this. You need to do systematic. I want theory, and after that, what is your input? You have to explain about the input data, and then what analysis you are going to do means in alignment with theory, and then I mean you have to explain your analysis uh, in alignment with the theory. Suppose if you are performing chi-square analysis, then you have to explain me what is chi-square analysis in theory and how it is performed in Python. So we are performing chi-square analysis by using a package called stats, I mean scipy. Inside we have module stats, and this stats has hundreds of techniques. You can finish everything. If you have this one particular module in your session, you can finish almost all analysis on your data sets. Now I am following an approach called simulations. I created a data set, a data variable using NP, NumPy array, and on that array I used a technique called chi-square and observation. Now, so what are we going to get back from this analysis? We get a chi-square statistic and we get a p-value. Now, can somebody help me how to interpret this? Whenever you are performing this chi-square analysis, I mean univariate, you are just comparing this, each of this value against, the middle value. I mean, the mean of the distribution. So mean is the expected value. So if you use, I think the mean will not work because unless we go back and import statistics, and then come here, mean, statistics, mean, OBS. Now should be able to say this is the central value. For this chi-square analysis, the expected value is 3. So we are comparing each and every value of this against, we're comparing each and every value of this array with 3, and then we perform. That is why even the chi-square value is also very close to central value. I mean the arithmetic mean of the distribution. Now coming to the p-value, this is where is one thing you have to explain me the chi-square value. This value is 1 minus the 3 whole square by 1, 2 minus 3 whole square by 2, it's a 3, something like that. So the sum of the differences between each of these values to the central value, and the total sum is the chi-square value. Now it is obviously nothing but a z value. Now coming to the p-value, here where the logic, I mean your talent has to be used when you interpreting the p-value. Now if you look at the value, it is close to, it is above 0.05. You see, is there anybody waiting? Yes, I think somebody is waiting. You see here, this value is 0.5, which is greater than 0.05. So in case if you choose to describe, take decision at 5% significance value, means 1 minus, if you are 90, I mean level of confidence, so 1 minus 0.95. This is your level of confidence. And now the significance value is going, I mean, 95% is level of confidence, which means you are confident that it is highly likely that this distribution can be a chi-square distribution if everything goes normally. If that is your assumption, then your level of significance, which means error, the error in taking decision is going to be 0.05. So that is why we call significance. Now at 0.05, when your cutoff, that is going to be the cutoff value or threshold value. So it is also known as the alpha in statistics. I think you already know all these things. I don't need to talk to you because you are in third year. You studied statistics. I assume that you know fundamentals. Now you just have to compare this p-value with a threshold value or a alpha value. Then you have to take the decision. So if you compare this alpha, which is 0.5, is far greater than 0.05. So which means we fail to reject the null hypothesis. So what is null hypothesis here? Can somebody tell me what is null hypothesis? Null hypothesis is the sample. I mean, when you are performing chi-square analysis on a single variable, it is called uh, the chi-square test of fitness. Okay, chi-square test of fitness, which means these values are not statistically. I mean, the difference between these values from the expected value is not statistically. I mean, the difference between these values to that of the expected value is not statistically significant. So the difference is not significant. So that is the null hypothesis. Now you see here we have 3 point. This is the chi-square value, expected value. The most likely, it is not actually expected value. The difference from the sum of the difference from the expected value, which is close to 3, and here the 3 is the expected value, and we have this. Now the difference is not statistically significant. So which means this distribution is fit. It has fitness to be proclaimed as a chi-square distribution. So every normal distribution is going to be the chi-square distribution. You don't need to worry. A normal distribution, from normal distribution we get every distribution. So this is a single variable. Now how to do this with bivariate distribution. Now in same NP array, suppose if you have an array of 1, 2, 3, 4, 5, and then you have something, uh, 5, 4, 3, 2, 1. And let me press. I just have to. I think. Do I need to put? I think I have to keep one more. No, here, because this is going to be the array of arrays. Now OBS, OBS, OBS. I mean observations dot t. I think this dot t is there on the right. Yeah, you see here 1, 2, 3, 4, 5, 5, 4. This is transpose. Okay, don't worry. Now stats chi-square analysis OBS And let's just execute this. You see here now you got two values. These are Chisquare. Windows became. Yeah, you got. I think you got three values here. No, I got four. 1, 2, 3, 4, 5. Okay, it is going to take each and 5 rows. No, no, no. That is not. I don't want that way. It is axis. Axis is equal to 2. It's not accepting the axis. Okay, 1. 1. I'm sorry. Now you got the 2. So axis 1 is I want to do it in column now. I mean, I don't want. Actually, it has performed the chi-square analysis by row, and that is not how I want to do the analysis. I don't know. These became a big trouble to it. Okay, shall I put them here? Okay. Now this is the chi-square value for the first, you know, guys, there was a problem in my, where they saved are going. Just disconnected and connected again. So you have to bear with me this because there is a frequent shorts in my my internet connection is not good. From morning there are power cuts, and also my connection is my data is disconnected and again getting connected. You have so by the way, you're all listen to me. Do you all there? Are you all there? I think you all must be able to listen to me. What is Zoom? Oh my God, where is my Zoom? I'm still there. But why? Hello, are you all there? Chart 3.
Yes, sir, we are there.
Yeah. Okay. So suddenly it disappeared. When Zoom windows disappear, I thought it is disconnected. Okay, fine, good. Now you see there are two chi-square statistics and there are two p-values. So I mean, it's none of the matter. So either it is in ascending or descending, doesn't matter. Distribution is a distribution as far as the chi-square analysis is concerned. So it has got a same chi-square value, and you can also perform analysis over your. So I'll try to create a data set. So let me stop. I'm just trying to do this uh, by myself. I don't know if I can do this or not, but let me try. There are three windows. Why? Shall I close this? Okay. Now I have dist 1 and dist 2, something like that. I don't know if you are able to see or not. I opened my calc. So I just simulate some data sets here, random one between, and then I don't need to do this. You can do yourself. Admit. Between 10 to 100, and then I just take some 15 and then I copy this. Now I save it as I'll go to the documents. I create a folder, data, and then admit. Now I have to give. I'm not able to see. Oh. So this is chi-square data. Hi data. Now let me save this as CSV file. By the way, if it disconnects, you just stay there. Okay? Don't. Yes. Sometimes it just disconnects. You don't need to. I just. And now what happens? I go back to my folder. I copy the documents. I think I have data here. I'm trying to copy the path of the file. Let me go back to. I think you are now. You should be able to see my. I think you are not able to see. I will take you to. What is the progress? So now you should be able to see the. Now I say data. Data is equal to. I have 10 minutes. So it is going to disconnect now. So all of you, please stay with me. Okay, stay back. I'll reconnect with you all. Now you say, I now go for import pandas as PD. So this is how you have to perform analysis. Now data is equal to PD dot read underscore CSV, and then I'm going to paste my path. And here I once again go back and take this CSV file name. Um, okay, so now I should be able to data head. So now we are using pandas. Okay, see, I got my data. Now let us do this chi-square analysis. Chi-square strats, chi-square. I don't know. I'm just trying to do this like that. Data. Now let me see. Yeah, you see. So suppose if you have till now what happened, I am just trying to do that with the help of it is better to write some but I'm not writing. Insert cell above simulations here, data simulation. Okay, okay, I'm sorry. No. And now here we have chi-square analysis. So you need to organize it this way. So I'm not doing like that. Insert cell above. And there are shortcuts, but I don't know. You can find out shortcuts for inserting, deleting, and all. Now chi-square analysis, and now change into markdown, which I often forget. Now come here. Here I think bivariate chi-square cell insert above. We have the h3. When I put the 3 times hash symbol, which means I'm creating header 3 h3. In HTML, it is equal to h3. Here bivariate chi-square analysis. Okay, sorry. This is what is the mistake I do often. And you can also do HTML tags. Now, yeah, here go for I'm going to insert a cell above H3. Now, chi-square analysis on real-time data sets. So it is not real-time data. I just created that data. There's nothing great about it. But you will be having your project-based data. In that case, you have to import the pandas. You have to import pandas and then import your data sets into your section, into your session, and then try to perform chi-square analysis. You see, this is a chi-square statistic for distribution one. I just called distribution one. In your data set, you'll be having a valid. Maybe this is age particulars of the sample one, age particulars of the sample two, something like that. Or it can be, salary of one category, salary of another category. So this is the chi-square statistic for distribution two, and now we got the p-values. You see, both of the p-values are close to 0, which means we don't have sufficient fitness in this data. So it is highly unlikely. I mean, what is the definition? I write it here. It is highly unlikely that this data can be highly unlikely to get this data. To get this data, the probability of getting getting see here, getting this data by random process is less than 0. So because the probability is less than 0. Now this is actually markdown. I have to press, you see, you will get the paragraph. So it is less than 0% that we get this type of data uh, in conformance with the chi-square distribution. So if we test this data, which is randomly sampled data, in In other words, we can say since the p-value is less than 0.05, 5% confidence level, we reject the fact that this data uh, is equal to the expected data. The difference between this data, I mean this, suppose if you take distribution 1, you have chi-square value 175.41 and p-value less than 0.05. So we can reject the null hypothesis that the difference is not significant. So we reject the null hypothesis, the difference is not significant. So the difference is significant. The difference between this distribution to that of expected distribution is statistically significant because the p-value is less than 0.05. Any questions? So I think I am a confusion master. Not that I know beyond the requirement. That is the problem. I many times. Any question? You can ask me questions so that so there is no confusion. I guess there isn't any confusion or any questions. You can write me yes or no. Question, please. No question. Are you all there? No, sir. Okay. So you just don't need to struggle with the p-value. Just compare it with standard value, and then take the decision that whether you are accepting the null hypothesis or rejecting the null hypothesis. This way you can perform chi-square data. Now the problem is not with this type of data. Most of the, I mean, chi-square data is non-parametric data, which means the one of the major advantages of the chi-square test is that it can support categorical data. I mean, whenever we have the categorical data, by default, as a matter of standard protocol, we straight away perform chi-square analysis instead of parametric tests like P and GEM. Okay, so most of the time we'll not be having data like this. So we'll have, I will share with you. I think I share my calculation with you. So now what I do, I am just going to create two categorical data, gender, and then education. Now, not education, salary. I call sal, male. I can do this within Python, but you need little mastery over simulations. Okay, that is why I'm performing, because it is easy for you to create this data. You're not going to create data. We will be having data. You need to use data from your project works or assignments. You should already. I keep the salary. No, I shouldn't keep salary like this. 0 to 20,000 and 20,000 to 40,000, because it should be categorical data. 40,000 to 50,000, and then fourth one 50,000 to 20 to 40, 40 to 60, right? 40 to 60, and then 60 and 60 to 80, 80 and above. 5 sufficient. Or I should. So now what I do, I just add some randomness to data, so that now how are you going to do chi-square analysis? Obviously, this is a nice example for the chi-square analysis, but the problem is how to create the cross-stack. The problem is not with it is not problematic to now say go back. I'll try my level best. So if I think I will be able to create the cross-stack. Now what we need to do, again, go back. No, so if I press, I think it is better to save this in a different, because we already use this name, right? Chi-square cross tab. This should be, I think, so I think it should be CSV. You can also import Excel files. Yes. Now let me share. Go back to browser. Please be cautious. It is